This lesson is on triangle proportionality. The first thing that we're going to see is our triangle proportionality theorem, which says that if you have a line that's parallel to the side of a triangle, then it intersects these other two sides. So it's got to intersect both sides of the triangle. Then what it's going to do is divide these sides proportionally. So this over this is going to equal this over this. Or as you see, AE over EB is going to equal AF over FC. But you got to know that these are parallel. So how can we apply that? Well, let's look at this one here. It says find the length of US. So if you'll notice, we got two parallel lines, and it's going to intersect this side and this side here of the triangle. What does that mean? Well, it gives me two proportional sides. So when I'm looking for the proportional sides, what I can say is the 10 over the 4. So this 10 over the 4 is going to equal the other side. The 10 goes with the 14 because it's from the smaller triangle, over this side here, the US that I'm trying to find. And so now I can just cross multiply. You might also do it this way, which I kind of prefer because it's easier working with one variable. So put an x. And we'll cross multiply. 10 times x is 10x. And then we're going to do 4 times 14. And so what we're going to do is we're going to multiply and then solve this. And so we get 10x is equal to 56. We divide both sides by 10, and x is going to equal 5.6. So the length of this particular side, US, is going to be 5.6. Let's go ahead and do this so that we can establish that we have the answer to the question. Alright, so let's look at the next theorem. It says that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. This is the converse, so just flip the hypothesis and the conclusion from our conditional statement. So if we know for a fact that AE and BE is going to be proportional to AF and FC, then what can we say? These two lines are parallel. So let's look at an example. It says to verify that DE is parallel to BC, which means we want to show that the proportional sides will match up here. So what we want to show is that AE to EC, or over EC, so from this triangle, is going to equal AB over DB on this triangle to show that these two sides will line up. What's the value of AE? 8. And what's the value of EC? 12. And we want to know if that's going to equal AB, which is 10, over 15. Well, you can do this multiple ways. We can reduce this. So if I reduce this, I can divide a 4 out of both of these. 4 goes into 8 2 times. It goes into 12 3 times. And I can divide a 5 out of both of these. So 5 goes into 10 2 times. It goes into 15 3 times. So yes, we know it works. The other thing you can do is cross multiply. You can do 8 times 15 is equal to 12 times 10. And what you're going to find is you get 120 equals 120. So that works too. So now that you've just proven that the sides here are proportional, we can say yes, DE is parallel to BC because the sides are proportional. Alright, let's look at the next theorem. This is going to be the two transversal proportionality theorem. It says if you have 3 or more parallel lines, so parallel, 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 and it intersects two transversals, it divides these transversal proportionally. So AC over CE will equal BD over DF. Let's look at how we can apply this. It says that we have an artist has decided to make a larger sketch of the trees. In the figure, they fill out all the information we need to know, but they want us to specifically find out LM as well as MN. Well, if we start with LM, we can kind of cover this up, and we can just work with this part here. So my 4.5 over 2.6 can equal, this is 4.9 over my LM. So you're going to cross multiply here, so we're going to have 4.5 LM is equal to, and then we'll do 2.6 times 4.9. And that will give you 12.74. And then we'll divide both sides by 4.5. to find out that LN is about 2.83 inches. And then we're going to do the same thing. So we can say 2.8 or 2.83 inches. Then we can do the same thing here for MN. And you can use this information or you can go back to the original. It doesn't really matter. I'm going to go back to the original here, 4.5 over, this is the side I want to know, so I want to go with the number that associates with it or corresponds to it, so 4.1 is equal to this side here, which I know is 4.9, over what I'm trying to find, MN. You may ask, why did I use those particular sides? Well, because these were the numbers that they gave me, so I don't have to worry about the fact that I rounded here, so try to avoid the rounded number. So we cross multiply. 4.5 MN is equal to, and then I'm going to do 4.1 times 4.9, and that's going to give me 20.09. Then we divide both sides by divide by both sides by 4.5, and we get that MN is about 4.46, or if we round it, it's going to be about 4.5. And that will give us, oh, you know what, here it is, to the nearest tenth of an inch. So now we're going to go ahead and change these both. 2.8 inches, and then this one is going to equal 4.5 inches. There they are. And I'm sorry if you didn't see all that because I had it down. Alright, and then finally the last theorem. It says that if we have an angle bisector of a triangle and it divides the opposite sides of the two segments whose lengths are proportional to the lengths of the other side. So in other words, you got a angle bisector, which means it cuts this into two equal angles here. What does that mean? It means that this side here, BB, over DC, is going to equal AB over AC. So look at kind of how they set this up. It's really important. They took the two segments that were created because of the angle bisector, so BB and DC. But then look, BB is on the smaller triangle, and it's on top, as is AB. It's on the smaller triangle. That's going to be important in setting up here. So you'll notice here on this problem, we've got the fact that this is an angle bisector because it cuts into two congruent halves here, or two congruent angles. So that means that this here, the x minus 2 over this other side that it cut into, x plus 5, is going to equal, where's that x minus 2? Well, it belongs to this triangle, so it's going to be 32 on top over the 40 on the bottom. And now we're going to cross multiply. So it's going to be 40 times x minus 2 is equal to 32 times x plus 5. Don't forget to distribute here. So we get 40x minus 80 is equal to, this is going to give me 32x plus, give me a second, I want to go ahead and do 32 times 5, 160. So we'll subtract 32x from both sides, and when we do that, we get 8x minus 80 equals 160. Then we're going to add both sides, or 80 to both sides. So we get 8x is equal to 240. Now we divide both sides by 8, and 8 goes into 24 3 times. Don't forget that 0. So it's going to be 30. But it says to specifically find PS and SR. All I did was find x. We got to make sure we plug it back in. So PS is going to equal x minus 2. Or in other words, 30 minus 2, which is going to be 28. And then SR is equal to x plus 5, so that means we've got to do 30 plus 5, which is 35.